Let's continue with section 1.7 with the next example. We have f of x equals to x plus 4 over x plus 5 to the fifth, and we want to find f prime of x. So, to get f prime of x, we take the exponent, move it to the front, so we get 5 times x plus 4 over x plus fifth to the fourth power, but because the parentheses contains the variable x, we're going to multiply by the derivative of x plus 4 over x plus 5. Now on the side, let's do just this part. Let's find the derivative of x plus 4 over x plus 5. So this is a fraction. It's in the form of n of x over d of x. So whenever we have a quotient, we have to use a quotient rule for derivatives, which says the following. We got d of x times n prime of x minus n of x times d prime of x divided by d of x to the second power. All right, so start with the denominator. It's going to, so d of x is x plus 5 times the derivative of the numerator. So the derivative of x plus 4, there's a 1 there, it goes to the front, so that's just going to be a 1. Minus the numerator, which is x plus 4, times the derivative of the denominator, which derivative of x plus 5 is still 1, so we get 1. All of that is going to be d of x to the second power. D of x is x plus 5, so this will be x plus 5 to the second power. Now let's go ahead and multiply this. So 1 times 5 is 5, 1 times x is x, so we get x plus 5. 1 times x is x, but don't forget the negative, so this will be a negative x. 1 times 4 is 4, don't forget the negative, this will be a negative 4, divided by x plus 5 to the second power. We got the x and negative x, this will give you 0. 5 minus 4 is 1, so this is 1 over x plus 5 raised to the second power. And that's this part. That's the derivative of x plus 4 over x plus 5. So we're going to say that f prime of x is equal to 5 times x plus 4 over x plus 5 to the fourth power times 1 over x plus 5 to the second power. Now you can leave your answer like this. For the homework, if you really want to simplify this a little bit further, you can. I'm going to show you how, but you don't have to. So what we can do is we can split this up as 5 times the numerator, which is x plus 4 to the fourth power, over the denominator. So 5 and the x plus 4 to the fourth are on the numerator. The x plus 5 to the fourth and the x plus 5 to the second, they're both on the denominator. And when you multiply the same base, you add the power. So this gives you 5 times x plus 4 to the fourth divided by x plus 5 to the sixth. And if you wanted to, you can simplify this a little bit further, but like I said, you don't need to. Next, let's find the derivative of 6 times 9x to the 10th plus 10x to the 6th. The first thing I'm going to do is I'm going to rewrite this using a rational exponent. So we have 9x to the 10th plus 10x to the 6th raised to the 1/2 power. For f prime of x, we take the 1/2 and we multiply it with the 6. So 1/2 times 6, this will give you 3 times 9x to the 10th plus 10x to the 6th. And if I subtract 1 from 1/2, this gives me negative 1/2. But because the parentheses contains the variable x, we have to multiply by the derivative of the parentheses, which is ddx of 9x to the 10th plus 10x to the 6th. Okay, anytime you differentiate something with parentheses, the parentheses contains an x, we have to differentiate the parentheses as well. So we're going to say that f prime of x, this equals to 3 times the quantity Now, because we can't have a negative exponent, I'm actually going to move this to the denominator. So it's going to be 3 over 9x to the 10 plus 10x to the 6. When it moves to the denominator, it becomes a positive 1/2. But anything to the 1/2 power is a square root, so it's going to be square root of 9x to the 10th plus 10x to the 6th. Let's differentiate this. So if we differentiate this, the 10 multiplies with the 9. This gives us 90x to the 9th. The 6 multiplies with the 10. And this gives us a 60x to the 5th. So on the numerator, I have 3 times the quantity 90x to the 9th plus 60x to the 5th. And on the denominator, I got the square root of 9x to the 10th plus 10x to the 6th. And then this will be the final answer for the derivative. Next example, we want to find the derivative of 4 times the quantity negative 2x to the 4th plus 4x to the 8th, that whole thing raised to the 13th power. So when we start to differentiate, I'll rewrite this. So we got f of x equals to 4 times negative 2x to the 4th plus 4x to the 8th to the 13th power. When we differentiate this, the 13 multiplies with the 4. So f prime of x, this is going to be 52 times negative 2x to the 4th plus 4x to the 8th raised to the 12th power. We drop a degree, but then we have to multiply by the derivative of the parentheses. Okay, and this happens every time there are x's in the parentheses. So if I simplify this, I'm going to get 52 times negative 2x to the 4th plus 4x to the 8th raised to the 12th power times the derivative of all this. So that's going to be a negative 8x to the 3rd. Multiply the 4 with the negative 2, drop down a degree, and then the 8 multiplies with the 4, so this gives you 32 x to the 7th. The 8 drops down a degree. Okay, and then there's not really much else we can do with this, so you can leave your answer like this, or if you want to rearrange it, you can be 52 times negative 8x cubed plus 32x to the 7th times negative 2x to the 4th plus 4x to the 8th raised to the 12th power. So either of these answers are going to be perfectly acceptable. Last but not least, at least for the video, we want to differentiate the problem f of x equals to 5x plus 4 to the 10th over 9x plus 7. Now notice this is a quotient, so we apply the quotient rule, which is this. It's going to be d of x times n prime of x minus n of x times d prime of x divided by d of x squared. Okay, so let's start plugging stuff in. Our denominator is 9x plus 7. So I'm gonna write all this out. I got 9x plus 7. And I'm going to multiply this by the derivative of the numerator. I don't know what that is yet, but I'm just going to write that out. So times the derivative of 5x plus 4 to the 10th power. I'm going to calculate this on the side, but I'm just going to write the formula out. Minus the numerator, which is 5x plus 4 to the 10th power, times the derivative of the denominator, which is 9x plus 7. Okay, so we want to find the derivative of 9x plus 7. So first, let's figure out what is the derivative of 5x plus 4 to the 10th power. Well, the 10 is going to come to the front, so we get 10 times 5x plus 4 to the 9th power. But remember, because our parentheses contains an x, we have to multiply by the derivative of the parentheses, which is 5x plus 4. If I simplify this, I have 10 times 5x plus 4 raised to the 9th power. And the derivative of 5x plus 4 is simply going to be 5. And we can take 10 and 5 and multiply those. So we get 50 times 5x plus 4 raised to the 9th power. And that's going to be just this part, which is the derivative of 5x plus 4 to the 10th. So I'm going to rewrite this as 9x plus 7 times the derivative of this is going to be over here. It's this expression. So it's going to be 50 times 5x plus 4 to the 9th. And I should actually have a bracket here. All right, minus, we got 5x plus 4 to the 10th power. We could show the work for the derivative of 9x plus 7, but that's just going to be 9. So that's our answer. Now to make this look a little bit prettier, let's write the 50 in the front. So this equals to 50 times 9x plus 7 times 5x plus 4 to the 9th power minus 9 times 5x plus 4 to the 10th power. And this will be our derivative. Oh, and I'm forgetting one big thing. I'm sorry. We have to divide all this by d of x to the 2nd power. So I left that till the very end. That's going to be 9x plus 7 to the 2nd power on the denominator. Okay, and that is our derivative. I know it's a lot of information, a lot going on. So as always, come to class prepared with questions.